So I'm Tyson, one of the HPC guys here at Sharcnet, and today I'm going to give a rather technical talk on building Nix packages. So much earlier actually, if you go back to our YouTube videos, there was a presentation on exploring alternative approaches to package management when we first started playing with Nix. Let me just advance to my first slide here. So I'm just going to say a little bit about what it is. And I should note, today is about packaging packages with Nix, which is very different than just day-to-day usage of Nix. So if you're left with the impression things are fairly complex, that's because packaging packages is fairly complex. Using Nix itself for just day-to-day normal activities is actually very straightforward. So what is Nix? Nix is a package management system. It can run is an entire OS system called Nix OS, where the operating system is also packaged by Nix, or it can run as an add-on package manager for your existing system. It supports Linux and Unix systems, most notably Mac OS X. This would be the other one. It provides around 13, I think closer actually to 14,000 packages, which is one of the nice things about Nix. Usually they're relatively up-to-date and stuff too. And you don't need super user access. I mean, you do need super user access to install it, but after it's been installed, you can install and remove packages as a regular user. So we put this on the cluster because lots of people want packages that aren't available, or newer versions than are available in our CentOS 6, and I guess we're on CentOS 7 now, so that should be less of an issue for a little while. And it also lets users run their own installations and removals. Now, it was originally a research project. I think there was I can't remember if it's a PhD thesis or a master's thesis, I think maybe a PhD thesis about advanced package management. And it's largely inspired by functional programming research. And a couple of the key points is it's atomic and immutable. And what does that mean? Well, atomic means operations complete or they don't. On a traditional system, you're probably aware of, you go and install something, and if it breaks halfway through, your system's left in a bad state, or it can be left in a bad state. Under Nix, either the package is installed and it succeeds in updating, giving you a new environment with the package, or it fails and you get the old environment back. So you don't have to worry about things getting stuck halfway between. Its packages are immutable, and some people view this as a good thing and some people view this as a bad thing, but that means once they're there, they don't change. So you can't have your system, old stuff that was working, be broken by updates, or alternatively, the people who don't like it will say it's not so easy you can't roll a security update in a library under an existing package. So that you can take as you will. It's reversible, so you can always go back to a previous state, which works well for using stuff on the clusters and experimenting. It's composable, which allows you, it's kind of like Lego bricks. You can build more and more complicated things out of your existing packages. And then it's garbage collected, so it keeps track of what's in use, and then you can run a garbage collector and it'll free it up. So a lot of these are sort of, if you're familiar with functional programming, some of the stuff that happens there. So that's Nix, the package manager. And now Nix is also a programming language. So the packages are specified using the Nix programming language. It's a lazy, pure functional language. I guess it's probably not that surprising, given that the package manager was also inspired by functional programming. And basically, it's used to create shell scripts that drive build processes. So it's important to keep in mind that there's Nix, the word Nix is used sort of in two contexts. So how do you install Nix? On Sharcnet Compute Canada systems, on our new clusters, Graham and Cedar, it will be coming soon. We'll have it installed there for you. Currently, we're just focusing on making sure everything else is working. This is sort of an add-on. On the existing Sharcnet systems like Orca, Monk, and so on, it's already installed. You just have to run module load Nix. If you want to reset your environment entirely, you can just remove your all the .nix files in your current directory and all the .nix files under your .config directory. We'll just reset it back to the state before you first loaded the module. Now on your own system, which is one of the beautiful things about Nix, is it's the same on your system as Sharcnet, so you can just transparently move between them. So if you want to install it on your system, you can just run this this curl, which fetches a installation script from the Nix site. You can have a look at that if you're worried about it rooting your system or anything, and then runs it. So for this demonstration, I'm just going to run it on my own system. Nixos org nix install, pipe it to shell. Yeah, so this just goes and downloads the initial package set for the Nix package manager itself and installs that in your system. And you have to have, it wants to put everything under /nix, so you need, this is the one little bit you need the root access for, is to create the /nix directory. So it'll ask me here for my password, and there we go. And it also modifies my bash RC to automatically source this file if it exists. So I will source that file, which just sets some environment variables so Nix knows where to look. So now I have the Nix command. If I press Nix, tab, I have a variety of Nix commands I can run on my system. So that's how you install it. And then if you want to remove it, you just do the opposite. So sudo remove, you just remove the Nix directory. And then as in the cluster, you remove the personal files under your own directory. And you can also edit your bash RC file to remove the line here it adds that sources this file if it exists. So that would be all it would take to remove it. So how do you use Nix? A quick overview is you can use the Nix Environment command, which modifies, well, actually creates new versions of your Nix environment. And your Nix environment consists of the set of packages you have installed. So you can query the installed packages. That's the ones you've installed. You can query the packages that are available, and this attribute path prints out the attribute path. You can query ones that are available under subsets as well. So for example, I could say, well, give me all the Python 2.7 packages is what I could specify with this attribute. And then once you see one you want, you can run Nix environment install attribute and specify the attribute, which is listed by these. And if you want to uninstall it, you can uninstall it by using the uninstall command with the name that was listed by query. If you want to update your environment, you can run Nix Environment Upgrade, which will go and update each of the packages to the latest package that shares the same name. You can update your set of packages with Nix Channel Update. You can kind of think of that as like a yum upgrade update or a apt-get upgrade. And finally, you can also, everything, as I said, can be rolled back. So this is sort of unique in Nix. Like under Debian, for example, you can't just roll back to the previous version before you install the package. But under Nix, you can. You just say Nix environment rollback, and it will give you the previous version. And in fact, you can even roll back having updated the package sets. You can go to Nix channel rollback, will give you the previous set of packages as well. So I'll just run through some quick examples of these commands here. So put that over on the side. So let's say Nix environment query available. Well, let's do Nix environment query first. So installed in my package, my system so far is just the Nix package manager itself. Now let's have a look at what's available. And especially on the cluster, this can take a while. It looks at a lot of files, and it's not that fast over SSDs. I mean, over NFS. Yeah, so here's the list of packages, and as you can see, it goes on for quite a while. Here we'll just put it through word count to give you an idea which just counts. So you can see there's 13,669 packages listed there. And we can actually, you can refer to packages by name, but I prefer to refer to them by their attribute path. So these are their names here. And then this is the attribute path, which is actually an exact specification of the package you want. So let's say we wanted, I don't know, we wanted Git, for example. So I'm just searching through this results here. So there's cgit, Git and tools darks. So yeah, so let's go with a Git minimal. So I'm just cutting and pasting it there. And so I want to install it. I can go Nix Environment. And there's another option you can specify when you list them that actually shows you the description of the packages as well. So Nix Environment install attribute Nix packages Git minimal. Installing Git 2140. And that will go and install it for me. And while that's completing, let me show you this here. So if you're on Google and you Google for Nix, or probably Nix packages, you will get the Nix packages website. So the Nix packages website contains these list of packages here, but it's searchable with a nice little web interface. So I can say search by name, so I can search for Git, and then I can see here what it showed me last time. Git, where are you? Yes, so here's Git 2141, Git minimal, and you can click on it. And it tells you the command to install it. So this is a shorter version with the single flags instead of the long flags. And the expression and what platforms it's available, and the home page and licensing information and a description of it. All right, and usually this installation is pretty fast. I don't know why it's taking so long. I'm going to just actually abort it and try again in case it just, yeah. So it just happened to have an unfortunate case of getting a connection that was, I have to wait for it to time out. So you can see it got Git, and it also got all of Git's dependencies. And now if I run Git, I say which Git, we can see we're running one in Nix. It's on a Nix path, and Git version. Indeed, it's 2140. So it's a great way to add packages to your system. And if we want, we can Nix environment. Now, if I run query, it'll say I have Git and I have Nix. I can uninstall it. Uninstall. I'm not going to uninstall Nix, because if I did, I would lose my Nix commands. But there we go. Which Git. Now I'm back to my system Git. And if I want, I can query. There, I've just got it. Now I'm like, oh, I didn't really want that last command I did, so let's go back. And there's Git back again. So that's pretty much the basics of using Git Nix, which is what most people will use. So I just wanted to bring that up, though, in case you wanted to sort of follow along on your own system and try building these things. It's very easy to install, as you can see, and it adds a lot of packages to your system. So the Nix package management actually happens in layers. So there's two layers. There's a derivation and an instantiation. So the output of the Nix language, actually, let me show you specifically what I'm talking about here. So if we go back to our web browser here, find him, there he is, and we look at the Nix expression, you can see the Git minimal, there's some sort of Nix expression. We click on that, and we blow this up large here. This is a package. This is a rather complicated package specification for Git. And what this does is this is written in the Nix programming language, which we will go over, and it tells how the package is supposed to be built. So ultimately, the output of this is shell script, and it's got lots of fancy options, like with manual, with Python support, send email support. So they've written something that has a lot of configuration options you can choose from. So what this is that when the Nix language runs this, it gets something which is called a derivation, which a derivation specifies how to build it. Basically, it's a specification of the dependencies, what the environment variable should be, and what program should be invoked to do the build. And then Nix will go and it'll set up as a sandboxed environment according to that specification, according to that derivation, and it'll build it, and then the results of that is known as instantiation. And that'll generate some output in an output destination directory, and it'll make a sanitized copy of that output, and that will be the actual installed program. So there's a couple of key concepts that go in there, and that is Nix is based around pure immutable builds. And these builds are identified by their build instructions. So if you have two things that give the same build instructions, that the output of those will be considered to be identical. So what do we mean by purity? Well, when the output is fully specified by the input, such as a typical example would be the math plus operator, the 2 plus 3 is always determined by what 2 and 3 are, namely the output is 5, then it's called pure. An example of something that wouldn't be pure is typical programming language that takes some arguments and then it also goes and does something, looks at something in the system in the background, because its result is going to depend on those arguments plus stuff that was not specified directly to the function. So Nix tries to go for pure builds, which means you have to fully specify your build. You have to give it all the dependencies, all the commands, and then that is ran in a sandboxed environment. So that's an environment that's contained, so the build process can't get out of it. And inside that build sandboxed environment is only those dependencies. And the expectation is if you run a build in the exact same environment, so you create the exact same sandbox each time, you're going to get the exact same result. If you don't do that, I would suggest there's something seriously wrong with your package, because there's no deterministic guarantees on its output. And then immutability, which means after you've created it, you can't change it. And what this means is that the output of the results of these builds, first of all, they only have to be evaluated once, because it was built in such a controlled manner that to do it again would just give the same result. And then by freezing them, so not allowing anything to change afterwards, we can share it with impunity. So if you ask for the same thing I've already asked, you can just use my results. If two different libraries require a dependency, they can safely share it because, well, first of all, they specified it should be built in the same way, so we know that this one output is good and it's good forever. And if you're from a mutable language, actually, it's tempting to think that that's very restrictive, because what it does is every time you want something new, you have to create it from scratch. But it's actually not very restrictive, and the reason is because it allows so much sharing. So when you create something new, you only have to create the new bit, and you can reuse all the old bits. So let's talk a bit about the language. So that's an overview of the package manager. Hopefully these things will all come into sharper focus when we go through it. So now the Nix specifications, such as the one we saw for Git, are written in the Nix language. So I'm just going to give you a really short overview of it. Comments, it's you can see it's really focused on making bash scripts. So they've sort of used the same comment as bash script. Layout, it's non-space and non-new line sensitive. So you can insert new lines wherever you want and spaces wherever you want. I mean, not in the middle of identifiers, but let's run. So there's another one here. I'm going to install Nix packages, and there's Nix read, evaluate, print loop, I think it's called. Yes. Which basically just is a sort of the same sort of thing you would get when you run Python. So here's welcome to Nix, and I can just enter program commands. So like 1 plus 1 is 2, and so on. So I'll just go over these quick examples. So let name 1 equal expression 1, name 2 expression 2, name 3 expression 3, and expression 4. So I can say let x equal 1, y equals 2 in, say, x plus y. And the result of that is 3. And then there's this with expression as well, which lets you bind stuff from a set. So we're going to get into sets later, but so with the set x equals 1, y equals 2, evaluate x plus y. So this is the exact same thing. Basically this one here, I specify what they are, each one separated by semicolons. This lets me give some arbitrary set, and it brings all those attributes into scope. Now there's a special type. Now you have Booleans, so of course you have true and you have false, and you have all the sort of regular operators on them. So true or false is true, true, and false is false, and so on. There's one that's a little bit surprising if you're not used to it, and that's the implication operator. So true implies true is true, true does not imply false, so that's false, and false can imply anything. And that's actually used for assertion. So basically, you say if the first thing is true, then the second thing has to be true as well. So that's a bit unusual. It's got negation, inequality, equality. It's got a condition statement. So if if say 2 equals 2, then I don't know, the string it's true, else the string it's false. And now, Nix being a functional language too, these can be embedded in as many bits as you want, right? So you could say, well, I'll give an example of that later using an if statement inside another expression. So those are Booleans. You've got your integers. I've already done several of these. So negation, addition, subtraction, multiplication, division. Now you have to be careful with this subtraction where you require the space, and that's because Nix allows your identifiers, so x minus 2, it does not consider that to be x minus 2. To Nix that means identifier x dash 2. So you will need a space in that case. Strings. So strings is just in single quotes. You have multi-line strings, which is you start them with a dot dot slash slash. It's quite a bit like the bash here documents, and then you can put a string over several lines, and then you end it with a double dash. That's useful when you're including script sections. And then it's got something like an anti-quote, which is like a variable substitution, except for it's more advanced. So we could say, hello, the answer is, and then in our anti-quotes here, we can actually put an expression. So we can say, so say, let x equal 1, y equal 2, and hello, the answer is x plus y. Yes, and the result, of course, has to be a string if it's going to insert it into your string. So there's I wasn't going to go into this, but there is a int, let me see. There's a set of built-in operations, and inside the built-in operations, I'm using tab complete to list them here. There will be a conversion from an integer to a string to I don't see it off the top of my head, but you would have to run the call to convert it into a string. So let's use something simpler. Let's just put 2 strings in there. So Tyson and, I don't know, Fred, say, hello. And then in here we could say Tyson plus a space and plus Fred. and sorry, it's x plus y, which is probably why you shouldn't make these examples up on the spot. Yeah, so basically, and that's really useful when you're creating your bash scripts, right? You can put a little a Nix expression in the middle that determines, flags to be passed or commands to be run depending on conditions at the time. Now there's path. A path is considered a path does not need to be escaped. It's identified by the leading slash or the leading dot if it's a relative path. So dot slash, I'm trying to think which directory I'm in. Yeah, so there'll be a dot bash rc. And then concatenation, you already saw me use the string concatenation here, so it's plus, so you can concatenate strings and stuff with pluses. So that's strings and path. Supports lists. Lists are separated by spaces, so there's the list of integers 1, 2, and 3. One of the things to be careful about is you'll often find yourself writing stuff like this. Probably not in that context. It'll be 3 plus 4, which will give you a syntax there. And that's because it's trying to make the list 3, and the next element is plus, and the next element is 4. So if you have stuff that's got spaces in it, you have to enclose it in brackets so it becomes one element. And lists are concatenated with a double plus, so you can concatenate them like such. Sets we've already seen, so it's just a set of semi-braces and key equals value, so x equals 1, y equals 2. There we go. You can have recursive sets. So by default, if I say z equals x here, it's going to complain because x is not an undefined variable. But if I say it's a recursive set, then each element of the set is allowed to refer to other elements of the set. And there you can see it's picked up the fact x is equal to 1, so z becomes 1. And there's various options you can do. So I can say on my set x, y, z, does it contain the element x? Okay, I'm not sure. Oh, yes. Sorry, I went up too many. Okay, there we go. So I wasn't reading this carefully, and I didn't count across to column 21. That's because I've got a non-recursive set, and I had z equals x. I was misreading that error message. So yes, it does contain the value. Does it contains the key r? No, it does not contain the key r. I want the value of key x. It's 1. The value of key z, it's 3. And these can be nested too, right? So x could be the set q equals 1, r equals 4, like that. And then I can say, well, get me x, get me q from x. And then you can also put in a default in case, so q, and then say I wanted t, which doesn't exist, so I'd get an error, or I can override it with a default, where I'm just using the string default. Attribute sets are really a key part of Nix, so they're fairly well supported with these powerful operations. And you can do overriding too, so I can say x equals 1, y equals 2 is my initial set, and then I'm like, okay, I'm going to override that by specifying a new value for x. X is 4. There we go. I can add elements, z equals 3. Missing my semicolon. There we go. I can remove elements. This is a case of using the null. Oh, actually, that doesn't look like that removed it. I just set it to null. So I guess I cannot remove elements. But yeah, so it allows me to extend it or redefine current variables. Now it's a functional language, which means you have functions as well. So we can define our functions. So we can say For example, we can define a function that takes an integer and adds 1 to it. So when you define a function, you just put the variable name and a colon and then the body. So this, my function's input is I, and the result is I plus 1. Lambda means an unnamed function. And we can apply this to an argument too, which is where at the bottom. So a function calls just a function followed by space with its operation. So we have set I to 2. That will give me 3. You can have multiple values if you want by what they call currying. So you just take another argument. Let's use I plus j. 2 plus 3 is 5. You can take in sets. So another way, a more traditional function would be like I comma j is a single value set of values, I plus j, and then we'd call it with I equals 1, j equals 2 is 3. It can also capture, if you want, you can capture the entire arguments. So I could just, this is one that takes a set of arguments, I and j, and it just returns that set. So I'll just get I and j back. And by default, if you specify an argument that is not spelt out, you'll see I got an error. It says, so it doesn't take a k. And you see you can pick up extra arguments by throwing in ellipses that do have extra arguments. And you can also set defaults. So say I wanted a w with a default value of false if it's not passed. So then inside my functions here we'll have w. It doesn't add it to the list of sets that was passed, but there will be a w which will have the value of false unless I say override it by passing an actual value of w with true. So yeah, so that's all the forms of the functions. By default, the functions are unnamed. If you want to name them, you just give them a name. So let increment equal I to I plus 1 in increment 2 should give me 3. Yeah. So that's the language. And that was kind of a very quick overview of the language. Let me just show you here. If you want to look up these details later, you can always just Google Nix language. And one of the top links will be the Nix manual. And if you scroll down through here, there is a section on Nix expression language. Here, and it goes through everything we just talked about. So it's a fairly compact language. And if you've used other languages, it shouldn't be too bad. So the actual set of Nix packages. Now they're basically the set of Nix packages, which is what I was, let me just get out of this Nix repeat, evaluate, print loop. So if we do the Nix environment query available attrib path again here, this is a set. This is a Nix packages set, and then these are all the attributes that set defines. And what these attributes are is they are Nix expressions which define how to build the package. And it gets this list from my, I'll have a ~/Nix default expression directory, and under that directory it'll go through and it'll look in each of these directories until it finds there's a default.nix, which will define the set of attributes. So this is my channels I'm subscribed to, which is basically like my Yum repos I'm subscribed to if I do Nix channel list. So I'm just subscribed to the normal set of Nix packages. So that inside this normal set of packages, which is what we want to look at, there's a packages top level all packages, which defines the top level attribute, and then it just includes a bunch of the packages under the packages directory. I didn't mean to say packages there twice. So let's go have a quick look at that in our Emacs here. Here we go. So I'm just going to go under the Nix default expressions, channels, Nix packages, which is the prefix for all that. So if we go under packages, top level, all packages.nix, this is the top level attribute. And we installed I believe it was a get minimal. And if we search through here, we will see get minimal has a definition. And we can look at these. So for example, manual is some package, I don't know, but it's basically defined in this development tools manual directory. So this is what I was saying by it's broken out into individual packages under the packages directory. So if we look under the packages directory, you will see it's all sorted by applications. So say we were looking at, I don't know, tools. And say we wanted system tools and cron. So here is a script, a Nix expression for building cron. And generally, when you go to build Nix packages, so I mean, here I'm sort of digging through it painfully by hand, just to give you an idea how it's structured. But that's what this website here. If we just go back to, I guess it was this one here, does for you, right? So if I just had looked up cron, there it is, and there's the description of it. I can click on it, and if I really want to see the package, it says it's under Package Tools Systems Cron. I can click on it here. And it takes me over to the GitHub page that kicks me over to that expression on the GitHub page. And here we can see sort of how a package is defined. So yeah, it's a function. It's got a colon. So as arguments, it takes in a list of the dependencies. And then it calls this standard environment make derivation call function, and it passes it a list of stuff. And what it's passing it here, it passes it the name, where to get the source file from, how to unpack the source file, whether to enable hardening, some pre-build commands, shell script commands to run. Here you can see the double quotes in quoting a large section of shell code, and in here you can see the anti-quote. So it's going to insert the send mail path there. A pre-install command, and these all have defaults if you don't specify them, and the defaults are configured for reasonable build systems. So if your package happens to be following any of the build standards, you basically just have to specify the source file. And then just some meta information. So this is where the description and the list of platforms it supports. You'll often see the list of who authored it, what its license was, and so on. So this is what I'm going to give a quick example of next, is actually writing one of these, which was the point of the lecture, now that we've only got 15 minutes left. But before I do that, I was just going to say that the default set of packages, it used to be that you'd have to go in and edit them, but they have now added this functionality, and that it lets you override them by putting files under config Nix packages overlays. And each of these files is just basically defines a function that takes two arguments, which is self and super, and then returns a set that modifies the existing set. So basically you already saw that double slash operation. And the two things your function's provided with is self, which is the final set of packages, and super, which is the initial set of packages. So in other words, the set of packages before you modified them and the set of packages after you modified them. And it may seem kind of amazing that you can get the set of packages after you modified them before you've actually modified them, but that's where being a lazy language comes into play. And so this is just an expression, takes the self argument, the super argument, and then it fills the scope up with the values in self. So it brings in the final set of packages, and then you can add your own packages. So let's give an example of doing some overlays. A typical example of what you might want to do an overlay for is if we go back here to all these packages again, so not the actual specific one, all packages Nix, and you can see these are all invoked through the call packages function. Now what a call packages function does is it looks up the function, and it looks at the arguments it requires, and it supplies them out of this default, the top level expression, and then you can specify overrides in this bracket, and it also adds an override attribute. So you can invoke the override attribute and apply further overrides. So old argument equals new value. And so a typical example, let's just do a semi-complicated one. So there's Emacs, which we can say is applications editor Emacs, and you can see here it says use overrides to enable these additional features. So let's have a look at what some of Emacs's options are. So I'll just load the file. If it specifies a directory, it's the default .nix file in it. And you can see, for example, with GTK3 defaults to true. So say I wanted it without and with X, if not standard environment Darwin. So it's going to compile up an Emacs with X support. So say I didn't want that. So I want to put an override of it. So I basically go into my system here. Here we are. I go into my .config directory. I make my Nix packages directory. I make my overlays directory. And then I can fill this up with my files. So let's open up a Nix config, Nix packages, overlays. Let's open up an Emacs Nix file. What is this file? Well, it's going to be, if we go back to my expressions here, it's going to be a function. It's going to take the initial, the final set, the main set, and with self, what we're going to do is we're going to find a new Emacs. So Emacs equals Emacs equals Emacs.override. Yes, so I want the original Emacs. So that's my super Emacs, and I'm going to override, and I'm going to say with X equals false, and I'm going to say with GTK3 equals false as well. Because you can see here it asserts with GTK implies with X. So I'll get an error if I don't shut off GTK3 when I shut off X. And there we go. So I'm just swooping in and making that one change. I'm taking Emacs, and I am taking the original Emacs, and I'm overriding it by turning X off and GTK3 off. And just let me have a look. I mean, unfortunately, there is a bit of digging in. It's actually, it's Emacs 2.5 is what I wanted to override. With Emacs being, you can see up here, Emacs is Emacs 2.5. So sometimes there's probably several Emacs 2.5. Well, there's already an Emacs 2.5 no X. So, I mean, an even simpler override would have just been Emacs equals super Emacs 2.5 no X. Actually, I just say Emacs 2.5 no X. But let's just comment that one out, and we will actually do the one where we do the override. There we go. So let's install this. Nix Environment, install attribute, sorry, I'll write these out long. Install attribute, Nix packages, Emacs 2.5. That should be a double dash. All right, and there you can see it goes and downloads Emacs. Now, when it gets partway through here, I suspect it's going to have to actually build it, and that's because I've changed, by default, the upstream Nix builds the packages with your default set of options. Oh, no, we got it built. Oh, yes, because there's already an Emacs no X built by upstream. So which Emacs? This is my Emacs now. And if I run it, you can see it brings up Emacs in a terminal because this Emacs has been built without X support. So that's sort of the most simple list of a change you would make here, which is basically I took in the original set, and I made some modifications to it, and those are applied. So let's actually package our own package here. So that was the overrides example. So I've just pulled out some examples of some packages that I have packaged up for users. So I'm going to actually just go with two relatively simple ones here. In the best place for reference of these, I should say there's a whole section on the Nix website. We'll just show you that quickly. Here, if we search for Nix packages manual, there's a section here on the standard build environment, the various phases associated with it. So unpacking, patching, configuring, building, fix up. And these all have default actions, so you only need to override them if your package has some sort of issues, it doesn't follow the standards. And stuff on cross-compilation and stuff. And then various languages, so like Beam, Erlang, Kotlin, Go, Haskell, Ertis, Java, Lua, Perl, Python. So basically, lots of these languages have their own specialized tools for installing their libraries. Python's being a very popular one. I'll do a quick Python example after I do this next example. And so they have a whole infrastructure that's been built up around it. Here's R, Ruby. So that's the sort of authoritative place to look for details. So let us package up Crypto Minisat, which was a package that was asked by us to package. So Crypto Minisat. There it is. It's an advanced SAT solver. And looking through the files here right away, you can see it's a CMake project. So it's built by CMake, which is good because CMake is a sort of standard building system. The other ones are AutoComp, the GNU Auto tools. The difference being those work well on Unix systems, not so well on Windows. CMake works better on Windows as well. And we can kind of scroll through it here, and we see by this apt-get some of the sorts. So it requires zlib, it requires boost, it requires M4I, whatever that is, SQLite, and probably some libraries that are also by default installed under Debian or Ubuntu, as that would be. So let's just start with that though. So overlays, we're going to make a crypto minisat.nix file. And again, it takes in the self, it takes in the super. We bring in, we bring in to scope the final package set, and then here we are. So we say, okay, we're going to add the attribute crypto minisat, and it's going to be this make derivation call. And the easiest way to do this, as I said before, was to look at an existing one. So we might want to pick something simple-ish. So if we just go back to our packages here and say tools, miscellaneous, see if there's something BC, that seems like that should be pretty straightforward. Yes, it is. This is a sort of minimal definition, standard environment. So make derivation. So we call this make derivation function. We pass it a recursive attribute set. And what are these attributes? Well, there's the name, which we'll just say is crypto minisat. And I think, what version are we on here? Just scroll back up here, have a look at their versions. It looks like 5.01 is the latest release. Name. There we go. The source. Now, there's actually special function for fetching from GitHub. Yeah, so there's a special function called fetch from GitHub. So we'll use that. Fetch from GitHub. I could also just specify where the source is, which would also work equally well. So source is fetch from GitHub. Owner is, who's the owner of this here? MSOOS. Moose. The repo is crypto minisat. Crypto minisat. The revision, and then all the rest has default values you can see here, so those are fine. The revision is going to be, I think it'll be this one here. Let's see what the source code is. Yes, so 5.0.1. Or it can actually be like a full git hash too if you want to use that. All right, so we specified the source. Now let's go back to our BC. Now, presumably there's no special configure. Build inputs. Build inputs. This is where I would specify my list of build inputs. The most important at this moment being CMake. If we go back and look at this, the package here again from the Debian list of inputs, we have the idea what it looks like it's going to require zlib. And the easiest way to find what these build inputs are is you looking them up. You're like, okay, zlib. Let's just go to the Nix search site here. I'll just search for Nix packages again here, and I can say zlib. And I can see the attribute name for zlib is zlib, so I just put zlib in there. Boost, so I'll include that. What do we got? Boost SQLite, M4RI. Don't have a good feeling about that. I don't know what M4RI is. We'll just leave that one out for now. Okay, and that's sort of what they've listed by default. So we might have to go back and append from that. We'll find out probably because you run it, it'll fail because it won't be able to find its dependencies. And then we can just add some meta information down here at the bottom, which I mean is entirely optional, but it makes it it's a good idea. So crypto ministat is an advanced SAT solver. Platforms, presumably it runs on all this platforms Nix supports. I don't really actually know that, but platforms all. Sorry, standard environment. Platforms all. And then the license, they didn't specify a license there, but standard environment lib licenses. I believe it was LGPL3. There we go. So now we can try and, let me just jump down to the end here, license. Fixed licensing to MIT. Okay, well, so much for LGPL3. MIT. Yeah, so let us build this package here. So we will try and install it. Nix environment, install, attribute, Nix packages, crypto minisat. All right, so then you get a Nix error. So it's line 26, 4, unexpected semicolon. And I can go to line 26. Yes, I forgot I'd already closed that. So we'll only close it once, re and build. So now we need a hash, which is so Nix knows that it fetches the right repo. And I don't actually know a hash off the top of my head. So we will just put an arbitrary one in here, modify this one so there's no collision, 7, 3, F6. There we go. Because it'll print out an error message saying that it couldn't. it downloaded it and the hashes didn't match. So it downloads the stuff it requires to build it, and then it goes to build it. And I guess looks like I'm pretty much out of time, so we'll just let this run to the point where it gives me this error that the hashes didn't match. There you can see it's downloading CMake right now. There we go. It says has this hash when this one was expected. So let's just put in the one it actually has. There we go. But that ensures that if somebody else goes in, I mean, this is part of the reproducibility, right? You have to have the same, start with the same source files. So if you specify the hash as part of it, and here we can see, okay, it needs the xxd command. So then we should go figure out what package xxd is and add it into the build inputs. And you just keep going back and forth like this until you get it built. There is also a handy command, which I'll mention now, which is the Nix shell command. And I like to run it with the pure command, which ensures that none of your local environment variables get in there. And so I can say Nix shell pure, and I can say Nix packages crypto mini slat. Pure package crypto mini stat. Yes. Oh, and I went and tried to build it. There's a I'll have to look up this command here. But you basically, it will give you it will kick you into the build root, well, a simulated build root environment. So it's not quite as tight as the official build root environment, but then it lets you interact and dig deeper into why your package is failing, and you can run all the various stages yourself. But unfortunately, we're out of time, so I'm going to have to stop the presentation there.